In this problem, we're looking at a projectile that is launched horizontally and falls down to a lower elevation. We have at least it stands at the top of a cliff and horizontally throws a pebble over the edge with a speed of 25 meters per second. The cliff is 30 meters above the water surface. We want to know two parts. A, how long does it take for the stone to fall to the water? And B, how far does it travel horizontally? Now, the first thing you want to notice here is that it says that it was thrown horizontally. It was thrown straight across. And what that tells us is that the speed that was given of 25 meters per second is actually the x velocity. So we have three different velocities here. And whenever you see the word horizontally thrown or launched, that means that the velocity given is the x. Because just like in math class, x means horizontal, your x-axis. So we're going to fill in that this velocity is 25 meters per second. If we look at the vector, it's horizontal at 25, at least in the beginning. It's horizontal at 25. That means in the beginning, it is not moving up or down at all. There is no y component in the beginning. So whenever you see the word horizontally, you know the velocity is the x, and the initial y components, the component of this vector here, is 0. So again, this horizontal word is very important. It tells us the velocity of the x is the one given, and the initial y will be 0. The other number that we're given here is 30 meters. And that is how far this projectile, this pebble, falls down. So this is a y direction. Again, x is left and right, and y is up and down. This is a y direction of a distance. So our y displacement is 30 meters, but it is going down 30, so it should be a negative number because it's moving down. We actually know one other number. We always know this number whenever it's projectile, and that is the acceleration. The acceleration is always negative 9.81 meters per second squared. So this number we will always be able to fill in. Now for part A, it asks how long does it take the stone to fall to the water? That is asking for a time. So we're going to go to our formulas, or equations, and we need an equation that has time in it. And I see that there are 1, 2, 3, 4 possible equations. So this one is out. Now in order to solve for the time, we need to know everything else in the formula. So the only other things that can be in the formula are Vx, delta y, VIY, or A. If I go through my options, this first option, I do have Vx, but I don't have delta x. So this one is out. In my y direction, this equation has delta t, and I don't know Vfy. I do know VIY and A, but I don't know Vf, so that one is out. I need to know everything else besides t. In this next equation, I know delta y is negative 30, VIY is 0, and A is negative 9.81. This is the formula that I'm going to use for part A. It has t in it, and everything else I happen to know. Going to and rewriting that equation, delta y is VIY delta t plus 1/2 A delta t squared. I now replace the numbers. I have negative 30 is equal to 0 times the time plus 1/2 negative 9.81 times the time squared. Anything times 0 is 0. So the 0 and the delta t both go away. I'm left with negative 30. Over here I have 1/2 of negative 9.81, which is negative 4.905, and still the delta t squared. Now I divide by the negative 4.905, and I get that 6.11 is equal to delta t squared. To solve for delta t, I must take the square root of both sides. And I get that delta t comes out to be 2.47 seconds. That's part A. Now in part B, we want to know how far does it travel horizontally. How far is asking for a distance, so it's either an x or a y. Horizontally means that we're looking for x. So in letter B, we're looking for delta x. Going to our equations, we need an equation with delta x in it, and there is only one. That's the only one. In order to use that equation, I need to know Vx, which I do, it's 25, and I need to know the time, which we just solved for, and that is 2.47 seconds. So this is the formula we have to use, and it just so happens we have everything in that formula. We'll rewrite the formula. Vx is delta x over t. Vx is 25. We're solving for delta x, and delta t is up here, 2.47. I solve for multiplying each side by 2.47, and I get that delta x comes out to be 61.8 meters.